Hello everyone. The topic that we're going to study today is solubility. This is from the chapter solutions. That is the very first chapter of the NCRT for class 12. For class 12, solubility is the topic that we are going to study. Okay. So let us understand what is this solubility. So solubility is the maximum amount of substance that can be dissolved in a specified amount of solvent at a specific temperature. So let me give you an example. For example, if you have a beaker of water which has 100 ml of water, let's say you dissolve sugar in this. So the maximum amount of sugar that you can dissolve in this 100 ml of water, that is the solubility, right? So at a specific temperature, because solubility changes with the temperature. So let's say I keep the temperature to be the room temperature, that is 25 degrees Celsius. So the maximum amount of substance that can be dissolved in the water, I have also specified the quantity of the solvent, that is 100 ml at a specified temperature. We call it solubility. Now it depends on the nature of the solute. It depends on the nature of the solvent. It depends on the temperature. Let us understand how. Okay. It also depends on the pressure. Let us understand these 4 points. Okay. Firstly, nature of the solute, right? So if you try to mix oil and water, will it mix? So definitely the answer is no. Oil and water will not mix because their nature is opposite, right? Oil is hydrophobic in nature. Water is hydrophilic in nature, right? So I can say water is like a polar solvent, right? Polar means, so water has a charge separation. I think class 11th chemistry, you must have studied this, that in water you see like there is a charge separation. There is polarity, right? But in oil, there is no polarity. Oil is non-polar, right? So non-polar substances do not dissolve in polar substances, right? So you must have heard this, that like dissolves like in, your younger classes. So oil and water does not mix together. Okay. Polar solvent, polar solute dissolves in polar solvent, right? Okay. So see, sugar, which is a polar solvent, right, would dissolve in water, but sugar would not dissolve in benzene. Can you see here benzene, which is a non-polar solvent, hence it will not dissolve, right? Oil, which is non-polar solvent, it would dissolve in benzene, which is a non-polar solvent, but oil would not dissolve in water, as we just saw in the image previously, right? Now let us understand the solubility of solids in liquids. Okay. Yes. So if more solute is added, what do you think? So if you're adding solute, after some time, if more solute is added, the solute settles down at the bottom of the test tube, right? So there is a process of dissolution and crystallization that occurs. If more and more solute is added, so what happens? Crystallization happens, right? Dissolution is dissolving of these substances in the water. So for solubility to happen, dissolution and crystallization, they have to be in equilibrium, right? So what is saturation? This is unsaturated solution. Like what is unsaturated solution? Let's say you take water and you dissolve sugar, but you can dissolve more sugar. Like there is a tendency for that solvent to dissolve more and more solute, that is unsaturated. So you can dissolve more solute in that, right? But what is a saturated solution? No more solute can dissolve. Even if you try to dissolve, it will not dissolve, right? Okay, so that becomes, but you can, dissolve more by increasing the temperature. That is called super saturated solution. Now, you must have seen when you heat sugar and water for a very long time. Yes. So you keep on heating it, especially if you're making some dessert, right? So if you heat sugar and water together, you heat it. After some time at the end, you will see crystals of sugar. That is called crystallization happens, right? That is a super saturated solution. Okay. Now, what is the effect of temperature? Right? Effect of solubility on solid and liquid. So let us see effect of temperature. So can you all just think what would be the effect of temperature on solubility? Yes, you must have observed that if you heat the sugar and water together, more amount of sugar can be dissolved, right? So if the process is endothermic, if you increase the temperature, the solubility increases. But if the dissolution process is exothermic, that means it releases heat. So if you increase the temperature, the solubility decreases, right? Okay. Let us say effect of pressure. See, pressure has, does not have any significant effect, because from your younger classes that solids and liquids are highly incompressible. We cannot compress them. That is the reason they do not have any significant effect. Now we are moving on to the next topic. So I hope you must have studied, you must have understood what is the basic of solubility. Let me quickly revise it for you. Solubility is nothing but, how much amount of solute can be dissolved in some amount of solvent and at a particular temperature. Let's say, I will just recall the example what I had given. If you have 100 ml of water, so it is the maximum amount of sugar you can dissolve in it at a particular temperature. Now, temperature and the nature of solute, solvent, that is what affects the solubility. The main thing is like dissolves like polar solvent, polar solute dissolve, and non-polar solute and non-polar solvent dissolve together. Okay, now we are moving on to the next topic that is called the Raoult's law. Okay, so what is the Raoult's law? Let us understand. Okay, yes. So we have water, and here water is evaporating. So obviously, if you take, so we have two systems over here. In the first system, we have water. So water evaporates, right? And we have kept like a lid on top of it. So whenever water evaporates, you can see there are some particles of water, like water vapors here, right? So since this system is closed, after some time, these water vapors, they will come back into the solution. That is called condensation, right? So water evaporates due to the normal temperature, which is their room temperature. And after that, the vapors will condense and they will form back, they will fall back into the solution, right? So what is this vapor pressure? We need to understand vapor pressure, right? So what is vapor pressure? When the rate of evaporation and rate of condensation is equal, right? So the pressure on top of the container, right? On top of the container, that is called the vapor pressure, right? So when the rate of evaporation and rate of condensation is equal, that is called the vapor pressure, right? Okay. So let us understand what is Raoult's law. So Raoult's law for volatile liquids. What are volatile liquids? Volatile liquids means liquids that, which have very low boiling point. For example, your nail polish remover. So if you would see your nail polish remover, if you keep it on your palm, it evaporates very quickly. So we call it volatile, right? Okay. So for a volatile liquid, the partial pressure, the partial vapor pressure of each component of the solution, it is directly proportional to its mole fraction. So let us understand it with the help of, okay. So for example, if in a container, I take two liquids A and B, right? I have A and B. Okay, so for a solution of volatile liquids, the partial pressure of each component, that means what is the pressure of A? And okay, so I have components of A here and I have components of B here, right? So partial pressure of A is directly how much pressure is exerted by A over here, right? The particles of, A that is proportional, directly proportional to its mole fraction in the solution. Similarly for B, right? The partial vapor pressure of liquid B is directly proportional to its mole fraction in the solution, right? And I hope you know what is mole fraction, right? So partial vapor pressure is directly proportional to the mole fraction. This is X, which is actually chi, which represents mole fraction. Okay, now we know that in any mathematical equation, we need to remove the sign of proportionality. So for that, we add a constant. Basically, here we are adding P naught, that is pure vapor pressure of the component, right? Vapor pressure of the pure component. So that means if I talk about the vapor pressure of A, that is equal to the pure vapor pressure of A, P naught A. So whenever we talk about purity, so we put this naught into the mole fraction of A, right? That would be the partial pressure of A in this solution. So this is the, the equation of the Raoult's law. Let us understand. So this is what I was telling you, that if I have one component, only one component in a closed system, so partial pressure now is only because of this one component. So partial pressure is directly proportional to mole fraction, right? And I have told you in the previous slide that to remove the sign of proportionality, what do we write? We write P naught 1 x1, right? So where P naught 1 is the pure vapor pressure, P1 is the vapor pressure of the solute here in the system. Okay. Now, if I have the second, that is my solvent. So my solvent, I'm naming it as P2 because solute and solvent, we're going to mix it together. So now P2, the vapor pressure of P2 is directly proportional to X2. That means it's mole fraction. The vapor pressure exerted by these, the particles of this solvent. So they exert some pressure right on the top. Some of the particles will be evaporated and then some will condense. But the vapor pressure is directly proportional to the amount of mole fraction. So P2 is directly proportional to X2 or the mole fraction of gas 2. So P2 is equal to Now to remove this, we write, what do we write? The pure vapor pressure and into the mole fraction. So P2 is equal to P2 naught into X2, right? This is the equation for, the vapor pressure of component 1 and component 2. Let us mix them together to find out the total vapor pressure. Okay. So here you have, let us move forward now. Okay, so according to Dalton's law of partial pressure, so if I make the solution, combine the solute and the solvent, now P total is equal to P1 plus P2, right? That means pressure at the solute and pressure at the solvent. We're going to add it up. So let us quickly see how we got this. So basically from the last slide, let us revisit the last slide. Please write this in your notebook, P1 naught, this equation and this equation. Please pause the video and write this in your notebook. Okay, so total pressure is equal to, the vapor pressure of component 1 plus the vapor pressure of component 2. And from the previous slide, we know that vapor pressure of component P1 is equal to P1 naught into X1. And for P2 is equal to P2 naught into X2, right? So I'm adding it together. Okay. Now, how did we come to this? Let us understand. We know that, the mole fraction of that any two components, like, for example, if I have two components in a system, so the mole fraction is always equal to 1, right? So can I write that X2 is equal to, so I send X1 to the other side. X2 is equal to 1 minus X1. Can I place it here? Okay, so it becomes P1 naught X1 plus P2 naught into 1 minus X1, right? So let us move forward. Please write it. Keep on writing with me. Okay, so I'm just erasing this. Right. Now, what do we do? Okay, so how did we come up to this equation? Let us understand. So I had P1 naught X1 plus P2 naught into 1 minus X1. And so now I will multiply this, right? Mathematically, please follow this, plus P2 naught, okay, minus P2 naught X1, right? So can I am going to bring all the terms which has the chi symbol, that is the mole fraction symbol, together. So I'm going to write P2 naught here, and then I'm going to write plus P1 naught X1 minus P2 naught X1, right? So what I'll do, I'll take out now mole fraction as common, plus X1 into P1 naught minus P2 naught. So I hope you got it, like how to do this. So this is the formula of the Raoult's law, which we will do, we will use it to solve numericals. This is the final formula, that is P total is equal to P2 naught plus X1 into P1 naught minus P2 naught. Let us see, how this formula changes or what happens. Okay. So let us understand the graph of the Raoult's law. Okay. So basically now we are assuming that P2 naught is greater than P1 naught. That means the partial vapor pressure of the second component is greater than the partial vapor pressure of the first component. That is, so how will this be greater? Only if the amount of X2 is greater than X1, right? Let us understand. Okay, let me teach you this graph. It is very simple. So firstly, we start from here, this y-axis. Basically here the amount of component 1 is 1 mole and the amount of component 2 is 0 mole. So obviously there will be no vapor pressure because of amount of component 2, because it is 0. But the amount of component 1 is 1. So the entire vapor pressure is P1 naught. Why? Because you have only component 1. So there will be pure vapor pressure of component 1, P1 naught, right? Okay. If I look here, slowly my component 1 reduces. It is becoming 0. Hence, the vapor pressure is decreasing, right? Okay. Now, if you see X2 here is 0, but X2 here, that is the mole fraction of component 2 is 1. So it is increasing. Can you see it is increasing? Why P2 naught is greater than P1 naught? Because the amount of mole fraction of 2 is greater than 1. That is the reason, right? So if I put second component in more quantity, obviously its mole fraction will be greater and its pure vapor pressure would also be greater, right? So now we draw like a dotted line here. This gives us that the total Dalton's law, that the total pressure is equal to pressure of the component 1 plus the pressure of the component 2, right? Let us move forward. Okay. So, Dalton's law, it also states that if y1 and y2 are the mole fraction of component 1 and 2, so I can directly say, so what was our formula? It was like P naught 1, okay, into X1. So if y1 and y2 is the mole fraction, so how we can say, like instead of X1, we can use P1 is equal to y1 into P total. right? And P2 is equal to Y2 into P total. So we can also use this. P total is the total pressure. Okay. Okay, so please try this, right? Just try this question and, just pause the video, read the question, try the question, and the solution is also, I'm showing the solution also here, right? And if you have any doubts, we can, again connect through Urban Pro. Right? So just try to solve this question, right? Okay. So thank you so much for paying attention. So this was all about Raoult's law and about the solubility. So again, let us quickly revise Raoult's law. What was Raoult's law? That the partial vapor pressure, right, of any gas above the liquid, so that is directly proportional to what its mole fraction in the system, whatever is its mole fraction, right? That is Raoult's law. And again, it is very important for the exam because many numericals are asked from the Raoult's law. Okay. So I hope you really enjoyed the session. If you want to study more, study the entire chapter in detail, so definitely we can get in touch through Urban Pro, right? Thank you so much.